Hi everybody. We're going to do probably two separate videos for this section on graphing rational functions because this first little bit is going to be about reciprocals. The reciprocal parent function, which is 1 over x, that is a rational function. A rational function is the ratio of two polynomial functions. So it should look like fractions. Rational numbers are fractions, so all those things you can kind of tie together. So the type of graph, it's a rational graph. When we're looking through 1 over x, we have, I think, made this on our parent functions worksheet before, but I made a table to kind of refresh what we're doing here. So if I just make a table from -2 to 2, I added some fractions in there as well, because if we take these x values and we plug them into 1 over x, here's what we should see in the table. I think we've talked about this before, but we know that 1 divided by 0 is undefined. We can't take something and divide it into nothing, so that makes it undefined, which means at that point we have what's called an asymptote. An asymptote is a line that you can kind of think of as a boundary line, where the function may approach or it may even cross, but it kind of tends towards usually not crossing that line. Occasionally we will see it cross, but it's kind of a boundary line where those points get close to it. Kind of like with log and exponential equations. Okay, so to get started, we know that at x equals 0, the function's undefined. So that means for the domain we have to say that x cannot be 0, and the vertical asymptote then, those two go together, would be that it is at x equals 0. So you see that blue line, dashed line here, that's the vertical asymptote, okay? And then what we should notice is no matter what values I'm plugging in for x, I'm going to get really close to 0, kind of like we've done with exponential functions, but it's never going to actually be equal to 0. So we actually have a horizontal asymptote as well at y equals 0, okay? And so we would say for the range then that y cannot be 0, and then that's assuming that it's all reals except 0, or all, as a way you could say that for the domain and the range. Okay, so that's just the parent function. Now we want to start talking about transformations. Hopefully you saw some of this if you did the Desmos activity last week. I'm going to go through and grade that for completion because it was kind of just you visualizing and discovering now what we're going to be doing here. So for a reciprocal function, the stretch factor can be in the numerator, and then we have x minus h and then plus k at the end, which is not a part of the fraction, okay? So h is that horizontal shift. Remember, if it's x minus h, we go right. If it's x plus h, we go left. The k is the vertical shift, like always. So if we add k, we go up. If we subtract k, we go down, okay? With the a value, the stretch factor, if it's negative, then we take those original points and we reflect them over the x-axis, okay? If a is greater than 1, again, it's a vertical stretch. If a is between 0 and 1, it's a shrink, okay? So we're going to focus on kind of being able to identify those things, but ultimately with these sections, guys, I want you to use Desmos and your graphing calculator as much as possible to kind of sketch the curves the best that you can. If we were in class, we'd really focus a lot on the algebra and making sure that we're getting all the little quirks of everything. But with this, kind of the basics. Which directions did it shift? Is it a stretch or a shrink? And then we want to go get some of those key points on the graph. So, okay, so what we're going to do first of all then is talk about how we find the vertical asymptote and the horizontal asymptote for a reciprocal function. So that means a reciprocal function looks just like this, okay? So all we have is x in one place in the denominator, and that's it. So if it looks exactly like this, then we can say that the vertical asymptote is at x equals h. The reason we know that is because what we're looking for is what's going to make the denominator 0. Just like up here, when x is 0, that's my vertical asymptote. So now here, if I have x minus h and I set that equal to 0, and I add h to both sides, I should get x equals h. So that's my vertical asymptote. Then if this is an up-down shift, and normally the horizontal asymptote is at y equals 0. If we get moved up k, then we know our horizontal asymptote is at k. Hopefully that kind of makes sense. All right, so writing functions, there's a couple on here where they give you a description, and then you have to write the function with vertical and horizontal asymptotes. I'm going to go through one of these, and then I put the completed notes in better penmanship because it's, again, kind of hard to write on Smart Notebook with what I have at home. So I'm going to post all of the notes there completed so you can have those. However you do the notes is up to you. If you want to print the blank notes that I give you and then copy stuff down, that's probably best for your brain to solidify it because you're writing it and seeing it and listening to it through the video. So that's probably what I would do, but the other options would be you can take my notes that say draft 1, and that's exactly what you're going to be seeing as I'm going through these video notes, and then the video notes complete means everything all filled in. So I don't care if you print all of those, you print one of them, or if you just copy some of the key ideas in your notebook, but you should probably have some of this written down, okay? All right, so number 1, it says the reciprocal parent function is reflected across the x-axis, then translated 4 units right and 3 units down. Write an equation to represent the new function and identify the asymptotes. So I'm going to start with reflected across the x-axis. I know then that there's going to be a negative for my a value. It doesn't say anything else about a stretch or a shrink, so I'm going to keep my a value as 1. Okay. Next thing it says translated right 4 units, so I know that's going to be with x in the denominator, and this is always opposite in every function that we've done. So if I'm going to go right 4, I'm going to say minus 4. And then it says 3 units down, so I'm going to say minus 3. Okay? And then to find vertical and horizontal asymptotes, remember for the vertical asymptote, I'm going to set that denominator equal to 0, solve for x. So that's going to give me 4. Horizontal asymptote should be equal to your k value. So that's at y equals negative 3. Okay, and then you can try 2 and 3. And if you are not sure, check them on the notes that are completed. Okay, graph each function. Now again, I would say if you want to go ahead and plug these in on Desmos, on a graphing calculator, but here's what I'm going to do. It is, let's see, I'm going to take a look at my shifting first. For this one, it looks like there's no vertical stretch or shrink or reflection. It doesn't look like there's a right-left shift at all, but we've got this minus 2, so that means everything on my original graph is shifted down 2. Okay, so if you plug it in the calculator, that's exactly what you should see. So for the rest of these, I'm just going to say you can go ahead and plug them in your calculator. And make sure that you are good to go with what you see with vertical and horizontal asymptotes. And then once we have the vertical and horizontal asymptotes, my horizontal asymptote I know here is negative 2. My vertical asymptote is just x equals 0 because there's nothing else in the denominator except for x. So then the domain and range are actually tied to those. So if I know my horizontal asymptote is at y equals negative 2, that means my range is all reals except negative 2. That's supposed to be a negative. Or you can just say y does not equal negative 2, and that's implied. The other thing is then domain is that we would say x cannot equal 0. Okay, I did a couple other functions here as well. Number 7, it looks like there's a shift right of 2, looks like there's a downshift of 2, and then there's a stretch of 3. Okay, so I just kind of tried to write that, keep track of that. So I know then that my vertical asymptote is at x equals 2 because I set my denominator equal to 0. I know that my horizontal asymptote is y equals negative 2 because that's my k value. So I draw those 2 dashed lines. I always do that to show the domain and range. So the domain is then that x cannot equal 2, y cannot equal negative 2. And to get more accurate points again, I just tried to plug it in the calculator and graph. Okay, those points. Now, the points are not very accurate because it's really hard to draw on here, so you can do better with a paper pencil than I can on the whiteboard thing that I've got going on. But number 9, moving on to that one. It looks like it's just negative 1 for my a value, so I said it should be a reflection. We're moving right 5, up 3, so that should be reflected in my vertical and horizontal asymptotes. My vertical asymptote is at x equals 5. My horizontal is at y equals 3, so that tells me domain and range. Since it's reflected, if you notice, kind of what we call the branches are in quadrants usually 1 and 3 mostly. So if there's a reflection, what happens is those branches end up being in quadrants related to 2 and 4. So kind of cool to think about. All right, last little bit on reciprocal functions. If you're going to print out a page of notes, this would be the one that I would print. So I think it's called like master notes or something like that. But it gives you the parent function, and then it gives you a couple of examples with all the transformation notes. And we already went through all of this stuff on the first page, but this is kind of nice because it gives you a couple things, and then it gives you examples, right? So we know that this moved the left one down 5. That's reflected in my domain and range and my vertical asymptotes. Okay, and then I can graph and get a couple more points. This one I've got a stretch of 2, and I've got a negative, and then I've got a vertical asymptote at -3. Since there's no k value, then we know the horizontal asymptote is at 0. Again, once I know vertical and horizontal asymptotes, I can find domain and range. The next video will be about rational functions. This is the other side of the note sheet I told you would be best to probably print off. So I'll go start this on the next video.